A common point of confusion in exams is the difference between series and parallel circuits. In a series circuit, we only have a single loop where all the components are connected one after the other. On the other hand, parallel circuits contain more than one loop, and this small difference completely changes how we measure current, voltage, and resistance. In this video, we'll focus on series circuits and some of the calculations you might need to do, while in the next video, we'll look at parallel circuits. So with this series circuit, since all the components are in a single loop, if any one of them is disconnected or broken, the whole circuit stops working. This is a major downside, and in practice, very few things are actually connected in series. Another important point is that the potential difference of the cell or battery is shared across all of the components. You might sometimes see this shown as an equation, which just means that the total voltage is equal to the voltages across all the individual components, the first component plus the second and so on. So, if our battery has a potential difference of 12 volts and the only components are two lamps, then the voltage across both must add up to 12. For instance, if these lamps are slightly different and the voltage across one is 8 volts, then the other must have 4 volts because 8 plus 4 is 12. But if both lamps are identical and have the same resistance, then each would get 6 volts, as they would split the 12 volts equally. Current, meanwhile, remains the same everywhere in a series circuit, no matter where you measure. We use an ammeter to measure current, and we place it in series, meaning anywhere within the main loop, it doesn't matter where exactly. We can also calculate current by dividing the total potential difference by the total resistance, which is a rearranged version of Ohm's law. Resistance works in a similar way to potential difference, where the total resistance is simply the sum of the resistances of each component. The green symbol for sum means total, and you'll often see it in physics or maths papers. For example, if the lamp on the left has a resistance of 4 ohms and the one on the right has 2 ohms, then the total resistance is 6 ohms. With that total resistance and our 12-volt battery, we can calculate the current using Ohm's law. 12 volts divided by 6 ohms gives a current of 2 amps. Keep in mind that ammeters generally have such tiny resistance that we can ignore them in calculations, which is why we haven't factored them in. Next, to calculate the voltage across a single component, we can use the current, which is 2 amps throughout the whole circuit, and the resistance of that specific component. So for the right-hand lamp with 2 ohms, 2 amps times 2 ohms gives us 4 volts across it. To find the voltage across the other component, we can either repeat the same method or simply subtract 4 from 12, which tells us there are 8 volts across the other lamp. And if maths isn't your thing, we can just use a voltmeter placed in parallel across the component to directly read the voltage. This one would show 8 volts. Even though voltmeters are in parallel, the overall circuit is still considered a series one. Finally, always remember that due to Ohm's law, components with higher resistance will always get a bigger share of the voltage. That's because more force is needed to push the current through the parts with greater resistance. This is why our 4 ohm resistor had 8 volts, while the 2 ohm one only had 4. That's all for this video. Hope it was helpful and see you in the next one.